All right. Hey, everyone. Good to see everyone here. Let's get started. We're going to talk a little bit about SDN and SONiC. And just by way of quick introductions, I'm Sunil. Gentleman over here is Bhagat. I'm sure a bunch of you guys know him. He's been part of the community for a while. And Reshma, who's also on the phone, I believe, from Intel, is going to talk a little bit more about some specific use cases with SONiC and SDN.
Yes, hello.
Okay, just by a quick, I want to get a quick poll here. How many of us know what PINS is, or a PINS project? Whoa, okay, I can go fast then. Yeah, we're going to give you, the idea here of this talk was really to give you a landscape of what's going on with SDN and SONiC and PINS specifically, and we're going to cover that in detail. Just at the outset, Google's big promoter of SDN. We deploy it heavily, we use it, we want to promote it, and has a bunch of benefits that we see, the traffic engineering part, the debugging part, the control and data plane sort of being separated part, and the aspect of being able to control the switches very, very specifically. Now, we do want to essentially broaden the scope here, or broaden SDN across the industry and make it prominent. And that's where I think our engagement with SONiC sort of came about, where SONiC being a pretty predominant switching OS. And the idea of bringing SDN to SONiC is where the PINS project came about, P4 Integrated Network Stack. And we have done a bunch of work. I'll give you a quick lay of the land there. We've done a bunch of work there. We've actually, the architecture as such, or the stack, if you look at it here, talks about two paths, the P4 runtime path to sort of program the switches, and the config management path for configuration and telemetry, which uses the standard open config that SONiC uses today. Okay. In terms of what we have been doing as a community, actually, last November, we did the first release, open-sourced SONiC pins to the community after 2 years of incubation and a lot of effort that the team had put in. With that came P4 runtime application, some of the reference code for SI applications for layer 3, packet IO capability, as well as integration with an open source controller called ONOS that came from ONF. So that was sort of the whole stack for any user to deploy SDN and SONiC together with the MVP product. Since then, we have actually been, again, pretty busy. As the users have been picking it up, we've been sort of fixing bugs. Batching requests have been introduced to deliver performance. There was a full talk that we gave at OCP on that, and Bhagat's going to touch a little bit more on that performance aspect of it. Build and packaging enhancements and so forth, and also tighter integration with ONOS and WCMP support. Sort of moving on to the release that is coming up, this month. One of the big things that we have added is some of the augmented packet IO support, as well as startup configuration. Also, PINS is going to be default as a default sort of option for SONiC, so users can essentially use it. So just taking this forward a little bit in terms of what else is going on in the community, there's a bunch of activities, and I highly encourage you folks to sort of participate in these. The first one I'll call out is the chassis work. Of course, SONiC has been doing a bunch of chassis-related enhancements. We would like to have, sort of PINS as the next step to that, and have a P4 runtime single sort of application running on it. We like to see the chassis as sort of one unit and have a P4 runtime application there. It is early. It is in early design from a pins perspective, but we really invite community interactions there so that we can take that forward. And then the pins on virtual switches, this is something that has been sort of a plan for us right from the very beginning. We believe scale testing of pins can only happen if it can be fully sort of set up in a virtualized environment. What we have done is work with a bunch of vendors to sort of enable virtual virtual SONiC applications with pins. And then one of the things that is in the works is P4DVDK. Ideally, the goal here is to have both the control plane and the data plane sort of all virtualized, so we can essentially scale out and create a test framework. And then Bhagat's going to talk a lot more about system-level testing and the test framework that we have been sort of pushing. And there's a bunch of work, again, going on in there. Standard interfaces, again, with the idea that we can have the community have certain tools that they can take this code and essentially test it in different system configurations. Finally, we are also extending SCI and SONiC to have a new sort of SCI pipeline being extended for new mass action tables, new protocols, the ability to sort of create new capabilities. And that's SCI generic path extensions. That's something we're going to talk about a little bit more. Bhagat and Reshma will talk about some of those use cases as well. So with that, Bhagat, why don't you take it over?
Thank you, Sushil. So let's talk about the test framework and topology. And this is one of the main reasons to talk about this, is that as we enable pins, we started with a prototype, of course, any project 2-3 years ago, started with a prototype and see how to bring SDN into SONiC. We have come a long way from that. We now have a stable pins stack across multiple different vendor switches. And we want to accelerate that one step further. And going forward, it really focuses on quality and ensuring that it doesn't matter which switch it is, once pins is on it, we'll be able to completely test end-to-end all the functionality that we bring in. And with that in mind, we have been working on a framework for testing, as well as enabling a lot of tests, implementing them, and open sourcing them. And this is the next stage for pins. We are very, very serious about this. We believe that unless we have quality, we wouldn't be able to enable velocity. Right? Velocity comes after. And so the next stage is really trying to bring a complete systematic testing of a controller-based SDN switching. We already have open sourced one of the frameworks, which is on Datra. And the next part of it, ThinKit, we are working on bringing that out. And then in combination, these two work together on a mirror switch topology within two switches to be able to test pretty much any SDN functionality in there. We have brought in about 600 to 700 tests that we run today inside Google. And we want to enable pretty much anybody and everybody to be able to run these tests and ensure that any changes that we bring in, as any features that we bring in, continue to work at the same quality. And along with quality comes, another focus is performance. Right? SONiC being a layered architecture and an eventual consistency architecture. Anything that you program has a front end and a back end, and things move one step at a time. When we are working on SDN, and there is a lot more about this particular aspect of it in the OCP talks that we gave this year. As we head towards bringing SDN into SONiC, we want to ensure that from the controller, we are able to send a huge amount of routes very quickly to the switch and be able to program all of that. And SI also has different objects. So if you want to send some routes, you need to send some next stops, and you want to send some refs. And how do you batch them up and send them? And then lastly, how can you do improvements in terms of reducing the amount of IPCs that happen? And what can we do there? We borrowed a lot from the way the ASIC DB layer things function in synchronous model, and we are trying to bring that to the AppDB. And these are performance improvements that we have done, and we have seen a lot of increase in performance after this, and this is another thing that we are hoping to upstream in this year. And what's next? So clearly, once we have the SDN-enabled SONiC, we are very excited about so many different projects going on in SDN-enabling SONiC. Once we have SDN-enabled SONiC, we want to have application controllers. Controllers that perform one or two specific functions is great because that brings in an incremental way of enabling SDN. It's not easy to move from complete routing to complete SDN, and that is not the goal either. You want to be able to figure out which applications it's beneficial to bring in through SDN. And we would also like to continue to have the legacy way of routing and other applications to run locally as well. So as we talk about SDN and SONiC, we want to be careful about which applications are optimal in terms of local and which applications are optimal coming from remote. And how do you match these things? How do you ensure that they work coherently, cohesively, without breaking each other? Right? That's a very important piece. And that's the reason we have built so many tests, and now we want to also start talking about incremental SDN controllers. How do we bring this slowly and ensure that somebody who's running legacy SONiC can, for a specific application scenario, start using SDN. And P4 helps a lot in this. The way that we have brought in SDN to SONiC is through a P4 RT interface. And just like you heard in the Dash talk, we have a way of verifying that the P4 works. We want to ensure that the pipeline that we are bringing in is defined as the same for across multiple vendors, so that it's very, very clear what is being targeted. Right? The advantage of P4 that it ties all the APIs together and brings together a well-defined pipeline. And with that, what we are trying to do is provide sample P4 programs for particular switch roles, say a TOR, a leaf spine, and then specific applications. And this, we believe, will clearly help us understand where and how functionality is defined. And it should be very, very clear once a packet goes in. You can run the same P4 program on a behavioral model, predict where the packet should go or how it should be modified, and then observe the same thing happen in the switch. Right? So that also enables us to test it in that fashion. And we already have the framework that we talked about. We already have tests that run a packet in a particular P4 program on a behavioral model, predict where the packet should be going and how it should be modified, and then run it in hardware and compare the result. Right? So this enables us to go to testing in a way where tests are dynamically written, doesn't have to be even hand-coded. Right? And when we get there, that'll be an ultimate goal. So we are on the path towards that. We already enabled different tests that are automatically written to predict things. And we have found bugs and issues that we have fixed as a result of that. So we'd like to enable and bring this to the community as well. With that, let me briefly talk about the generic extensions and then hand it over to Reshma. So generic extensions allows us to bring new use cases and scenarios into SONiC. And this is important because while we have the existing functionality, it's important to innovate. It's important to bring things that are new as we find use cases for them. And having a P4 program to represent the SI pipeline today, we can extend that P4 program to different use cases. And these use cases can come from pretty much any customer. And they can, as long as a SI API is available or a generic extension can be added, we would be able to create and try out that pipeline. And that's important, an innovative use of the P4 program aspect of doing pins. With that, I'll hand it over to Reshma. Reshma.
Thank you, Bhagat. Let me show. Is it okay to start now? Are you able to see the slides?
Yes, Reshma, please go ahead.
Wonderful. I will advance the slide. And today I'll be talking about generic SI extensions and also its application in the SRv6 service chaining. With the aim to allow logical extensions to the standard SI pipeline, generic SI extensions adds the infrastructure in SONiC to realize novel features by adding new match action tables in the SI pipeline. It mainly gives the user the flexibility to extend the existing SI feature or protocol or have proprietary IP in their applications that they want to write in the secure environment of SONiC pins. At the same time, have uniform management interface across their applications and the devices in the network. Users would assume the underlying SI pipeline as a baseline and want to create new tables as touch points to extending SI features. By adding a couple of extension tables in certain places in the pipeline, and they're programmed in a manner that is independent of the data path. These extension tables could change metadata that is used by the pipeline, or they could create new metadata that is not used by the pipeline's regular flow. Here are some of the use cases that could utilize generic SI extensions, and some of them are prototyped, and we will be upstreaming the P4 for it. Within the pins architecture in SONiC, we have made these enhancements to allow for more generic way to program the extension tables. P4 runtime intercepts the P4 info to translate the new extensions table match action fields into the application DB. In addition to that, a new table definition database is also created to record the inter-table object dependencies. In the pins P4 org, we added extensions table manager, which processes the new tables and creates a dependency graph. It first creates the object type key value pair for the dependent object and performs lookup in the associated cache to retrieve the object ID and to make the corresponding SI calls and eventually add into the ASIC DB. This aids in cross-referencing between the new pins extension table objects as well as the existing SI objects. Working with the SI community, we also introduced a new programmable SI object, which allows for a more dynamic definition of the extension table objects and attributes, and incorporates the essential metadata to seamlessly program them in a given target hardware. A little bit about SRv6. The main challenges are mentioned here: putting control in the hands of the network operators and giving them the control to solve the problems they face with when traditional protocols are sometimes insufficient, mainly to meet their business SLAs for latency or seamless connectivity across network boundaries. With that as a goal in mind, SRv6 provides programming ability, traffic engineering capabilities, and deployment simplicities to network administrators. Comm service providers are embracing SDN and IPv6 networks because this combination allows them to build large networks and cater to SLA guarantees. We wanted to add all the features under SRv6 umbrella in the SI right at the beginning, and then incrementally add implementations for those features in SONiC in phases. From Intel, partnering with Alibaba, we added head-end behaviors, h.ncaps, h.ncaps reduced, b6 ncaps, and end-node behavior such as n.t, n.x, n.dt46, etc. into SI. In 2021-11 SONiC release, we added the SRv6 implementation in SONiC to support ingress, transit, and egress nodes, anycast SID, and traffic engineering with SID list. This year, we added microSID, and it will be available in the SONiC 2022-11 release, a collaboration with Cisco. We look forward to adding more features like SBFD and enabling FRR integration into SONiC, which enables more policies like B6 and CAPS. Quickly, SRv6 org has been added in the SONiC SWSS module. Application DB contains SID list and policies populated by the SDN controller. The allocated addresses for the head-end function lookup are part of the steer map, and the route table programs the SID list to next hop association. Coming back to pins, SRv6 gateway needs to terminate the incoming IPv4, IPv6 traffic and originate SRv6 tunnels. SRv6 proxy is needed when the network has portions of SR unaware devices and to bridge the SRv6 islands. Service chaining requires the devices to run the network functions of load balancing, NAT firewall, etc. in a SR aware network. All these requires DCAP, NCAP, modifying packet headers using predefined rules from SDN and can be programmed by pins generic SI extensions. Here is an example of a simple load balancer implementation. We terminate SRv6 for the flows destined to MySID and pop the segment in the SRH, load balancer traffic, and send to the backend nodes. Load balancer block can be added via generic SI extensions, and in SONiC, the application DB and ISIC DB entries are as shown here. While SRv6 is a preferable option for service chaining because of its stateless nature, running it over a PIFA programmable switch such as Intel Tofino can bring even more benefits. We really like to encourage everyone to participate in the Pinsburg group meetings that we have once a month and talk to us, contact us more for further information. Thank you. Any questions?
We can have the dash through the pins. Is it correct?
That's an interesting question.
There is a PIFA model there.
Yes.
So it can be P4 runtime there. Right. So if your device P4 capable, you can, and you have SONiC on the dash, the DPU.
I'd welcome Lehu and Gohan to add on to whatever I'm saying. So my understanding is that Dash today tries to achieve the same things of calling the SI API through the GNMI and the APIs, right? So the way you program things into the switch is to come through GNMI, and then from there do the SI API. In the case of pins, the same goal is achieved by coming through the P4 runtime API. So it comes through the P4 RT interface, which is capable of understanding a P4 pipeline. And that's one of the main differences. But both of these are enabling different SDN use cases into SONiC. And absolutely, they are very good models.
It definitely provides the optionality to use different types of interfaces. I think in Dash, it's very specifically handled to implement all the use cases that we have discussed in the Dash. So it's very precise and complete there. But definitely, there is a bit of optionality.
So, Bhagat, great talk, and Sunil and Reshma. So, quick question on the P4 that you guys have done for the SI. So today, if someone were to introduce a new SI API, that essentially, modifying the SI logical pipeline, and that would really mean that you define some sort of a modification into SI.P4, and then, go ahead and, introduce that change in the SI.P4. So you mentioned that, you're yet to introduce some of the test cases, but today, if I were to modify a SI.P4 and would like to basically, commit into the SONiC, do you guys have any test cases there to introduce that? I'm not introducing any regression.
So we are working in terms of upstreaming these tests and the test frameworks, and it's a matter of time before they're available to everyone. At this time, what we are doing is we are also downstreaming the SONiC releases and running tests on them to ensure that nothing gets broken as features get added. So we'd definitely be interested in collaborating and making sure that if there is any breakage, we communicate and work to fix things.
Okay. Right. And one of the ways you are basically bringing those test cases are through ThinkIt for the P4?
That's right. ThinkIt and on Detra. Yes, that's right.
Thank you.
Thank you very much.